So when we are working with trigonometric functions, they allow us to find the ratio, define the ratio of the sides of a right triangle based on the acute angle. But what we're going to do here is, as we solve for the angle measures of right triangles, we're going to take those ratios and then determine what the angle is. So basically, we're going to work backwards. And in doing so, what we're going to be talking about are the inverse functions. And some of the things that we want to be able to do is we want to be able to write equations that can be used to solve unknown angles in right triangles. And we want to solve for unknown angles of right triangles using these inverse trig functions that we're going to speak about. And then we want to be able to apply these inverse functions to solve real-world problems. And we'll do an example with that. Some things to think about, words here: angle of elevation, angle of depression. So looking at those, if I am here and I look up at a plane, right? I look up at a plane, that is an angle of elevation, okay? Angle of elevation, because I'm looking up. Now, if I'm standing on a mountaintop, and I am looking down at the automobile that I just hiked away from, right? Not a very good looking automobile, right? But if I'm looking down, then this is going to be the angle of depression. So just understanding that. And then of course the horizontal would be if I am looking straight across to somebody else on another mountaintop, and they used a ladder to get up. They cheated. If I'm looking straight across, this would be considered a horizontal. Okay, horizontal. Horizon, 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 whole, horizontal line. Okay, and then this thing right here, is theta. It stands for angle measure, angle. So just some things that we're going to look at and use as we go forward. So looking at the inverse trig functions, to look at them, let's think of the original functions. Our trig functions allow us to find the ratios of sides when given an angle. And what we were using there is we had that, or let's just go with SOHCAHTOA. We had our sine is equal to the opposite over the hypotenuse. Then we had our cosine is equal to the adjacent over the hypotenuse. And then my tangent was equal to the opposite over the adjacent. And we were using these to find the given an angle, right? We were able to find what the ratio was. And in doing so, if I look at this triangle, I might say that, so we have identified here ABC, triangle ABC. I have a side length here of 4.25, a unknown hypotenuse and leg, but I do know that angle A is 58 degrees. So if I wanted to turn around and say that the sine of 58 degrees is going to be equal to the opposite, right? The opposite over the hypotenuse. Well, the opposite is going to be 4.25 over the unknown C value, and using my inverse operations, go ahead and isolate or work to isolate C. And then I have C times the sine of 58 degrees is equal to 4.25. And then I can divide both sides by the sine of 58 degrees because I'm continuing to isolate my unknown variable. And then C turns out that it is going to be equal to 4.25 over the sine of 58 degrees, which we turn out, and we can put that in the calculator, and we find out that it is approximately 5.01. So we were able to find some of these, but now what we're going to do is working with our inverse functions, we are going to go backwards from that. So the inverse functions allow us to find an angle measure given the ratio of sides. And you may recall that the inverse of a function reverses the input and output values of a given function. So my inverse functions will turn out to be not sine, so it is going to be written like that. That is going to be the inverse of sine, and we would say arc sine is its terminology, and then cosine would be cosine to the -1, and that is going to be arc cosine, and then tangent is going to be arctan. So that's how we would identify that as we're working backwards. So what it does is it allows us here to, if we were to have arc sine of 1/2, and we put that in the calculator, that is going to tell us 30 degrees, or it's going to tell us 30, and then we know that that is going to be degrees because we're going from ratio to measure. And the same thing with the arc cosine, right? The inverse cosine, inverse function of 1/2, we are going to find out that that is actually going to turn out to be 60 degrees. And you can actually figure those out just by using your special right triangles, but it will give it to you if you use that in the calculator. And what you can see here is what I've done is I've gone ahead and put it into the calculator, and you can see that here is my inverse functions. Of course, my trig functions right here in the calculator, and then the inverse functions are right above it in blue. So in order to access those, you would use your second to get to the blue commands. And what I've done here is, if you notice, I put in the inverse of sine of 1/2, and I did say that it was equal to 30 degrees. Well, this isn't 30. What happened is I needed to check the mode because the calculator mode was in radians, and I needed to be the calculator mode in degrees. And I've looked at that at previous lessons, but just so you know, anytime you pick up a calculator, it may not be in the mode that you're looking for, so make sure that you check that. So here we go. I put in sine. The inverse sine of 1/2 is going to be 30. The inverse sine, or inverse cosine of 1/2 is 60. So again, a lot of these things, it will fix it, but you do have to understand what you're looking for. Again, given the ratio, we can figure out the angle using our inverse functions. On the other hand, our trig functions, given an angle, we are able to determine the ratio with our trig functions. So those are, inverse of each other. So as we look at this, we want to find the measure of BAC. So BAC, so this unknown angle right here is theta, right? That's what we're looking for. We're looking for theta. And I could use several functions. So if we look at, in reference to theta, we have 12, right? 12 is going to be the opposite of theta. The hypotenuse is 13. 13 would be the hypotenuse. And then 5 would actually be the adjacent. So if we were to go ahead and calculate this, I could say when it comes to theta, remember that the arc sine is going to be, the arc sine of theta is going to be the opposite, right? The opposite over the hypotenuse, so that would be 12 over 13. The arc sine, or arc cosine, is going to be the adjacent over the hypotenuse, which is going to be 5 over 13, or the arctangent is going to be the opposite, which is 12 over the the opposite over the adjacent. And so that is just coming up with the ratios. And let's see here, what do we do next? We could possibly work with the calculator. And what I've done here is I've gone in, I've input this into the calculator, and of course I used my I used my second and my sine to get arc sine, and I went ahead and plugged in the ratio that we came up with. We said the arc sine of 12 over 13, which is my ratio, and when I input it, the degrees are going to be 67.38 degrees. And I went ahead and I input all three. It may or may not be necessary, but I'm trying to show you that it works. So I could have used any one of these ratios that I came with, arc sine, arc cosine, arc tangent, and come up with the proper degree measurement as long as I had the ratios proper, and that's one of those things that we were learning a few lessons ago, is making sure that we can label a triangle with the opposite, the hypotenuse, and the adjacent depending on the angle. So there you go. We were able to figure out that measurement of 67 degrees. Now, find the angle measures of x and y. This is going to be the same thing, and you can pick any of these, but if I just go ahead and I'm going to worry about x, I'm going to look for the opposite. I mean, hopefully you can label all these: the opposite, the adjacent, and then the hypotenuse. The opposite, when I'm talking about angle x, the opposite of that is going to be 2.4. The adjacent is going to be 10, and then the hypotenuse is going to be 10.3. And judging by those measures, I hope you realize this triangle is not drawn to scale. And if I go ahead and I look at angle y, right? Angle y, my opposite is going to be 10. My adjacent is going to be 2.4. And then my hypotenuse is going to be the same, right? There's only one hypotenuse to a triangle, and the hypotenuse is going to be 10.3. In reality, this triangle looks something like this. It's much more flat triangle than that appears here. But for not drawn to scale, and we want to make sure that it is easy to do. So I can pick any ratio here, and I could say, hey, arc sine is going to be the opposite over the hypotenuse, which is going to be 2.4 over 10.3. Arc cosine is going to be the adjacent over the hypotenuse, which is going to be 10 over 10.3, and then the arctan is going to be the opposite over the hypotenuse, is going to be the opposite, we said, was 2.4 over the hypotenuse, which is not the hypotenuse, sorry, the adjacent, which is just 10. And plugging those into the calculator, let's hope we get the same answer. And depending on the decimal, if you put this in the calculator, you're going to end up with x is approximately 13.5 degrees, and my y is going to be, well, the other portion of that, which would be 76.5 degrees, combined would give me 90 degrees. So just different ways to input and calculate the angle measures depending on which ratios that you're using. And then talk about angle of elevation and then the angle of depression, and if we want to use it to create a real-world scenario. This example is Rakeem is flying his drone at the park, and he spots a drone at an angle of elevation that he estimates to be 30 degrees, and the remote control tells him that the drone is 102 feet above the ground. And if Rakeem is 6 feet tall, how far is he from the drone? Okay, well, let's see here. Rakeem. Rakim is here with his little remote control, and if we want to say that at a distance, right, it tells me that the drone is 102 feet above. All right, so I have this drone, right, and he's flying his little drone, and it is 102 feet above ground level. Here's ground level, right? And then if we know that he is 6 feet tall, and of course this is not drawn to scale, I know that this distance is 6 feet because he is 6 feet. And then it says that he estimates to be 30 degrees. The angle of elevation, he is saying he estimates that this angle looking up is 30 degrees. And it says, let's see here, he spots the drone at an angle of elevation of 30 degrees. We have that in there. The remote control tells him that it is 102 feet above the ground. Okay, and then he is 6 feet tall. And then how far is he from the drone? So we are trying to figure out this value right here. And we know that given his angle of elevation, if we drew this horizontal line straight across, right, that this point to this point is not 102 feet, but it's 102 minus 6. So this measure, what would be the opposite measure, is actually going to be 96 feet. Because 96 plus 6 is going to give me that 102 feet. So if I want to figure that one out, how far away is this drone, figuring this value out here? This is my hypotenuse. I'm given the opposite and an angle measure. So let's see here. I have the sine of 30 degrees is going to be equal to the opposite, which is 96 over some value of x, right? We'll call that x. And then just do the inverse operation. So I'm going to go ahead and multiply both sides by x because I need to get x in the numerator. And then it tells me x sine of 30 is going to be equal to 96, and then I'm going to divide both sides by the sine of 30. And then as I figure this one out, it tells me that x is going to be equal to 96 divided by the sine of 30, and that is going to be equal to, so he should be, that distance from the drone should be 192 feet. So this length is 192. And if we wanted to find out at a horizontal level, as they say, as the crow flies right here, what is this length? You could use the Pythagorean theorem to figure out, you know, if that drone were to fall out of the sky right now and hit the ground, how far would he have to walk to get to it? And that might be an issue. Why do we care, right? Well, it could be over somebody else's property. It could be a matter of, are you exceeding the drone's command and control distance, capability of controlling it? So those kind of things you want to make sure that you're aware of. So again, we can use our functions to figure out distances. And we want to solve for those angle measures of right triangles, and remembering that we, looking at elevation and depression and the horizontal were some words that we needed to make sure that we were comfortable with. And then our inverse functions, be it arc sine, the inverse of sine, arc cos, invert of cosine, arc tan, which is the invert of tangent. So working with our inverse functions to figure out angle measurements based on the ratios.